All right, so I just sent out this practice quiz for chapter 9 on section 9.3 and 9.4. So I'm going to go over the answers. Hopefully you did this all first and you're just correcting your own work and kind of grading yourself to see if you understand the material. So we're going to be using law of sines and law of cosines. So the first thing is you need to determine when to use which one. And then the other time is you need to make sure you check for two triangles when you need to, and I'll explain what that is. So for the first one, and for all of these, really, you just want to start by writing the three angles and the three sides that are given to you. So for this one, they give you angle B is 30.6 degrees, side B 7.42, and side C 4.54. So immediately, I know that I'm going to go ahead and use law of sines. And the reason I'm going to use law of sines is because I have an angle across from a side. I also know that I have to check for two triangles. Two reasons. One, because they only give me one angle. That's the first reason. And because that angle is acute. If that angle was obtuse, you would not have to check for the second triangle. But because that angle is acute and you're only given one angle across from a side, it's law of sines. Again, it's law of sines because you have angle B and side B. Checking for two triangles because you only have one angle and the angle given is acute. So I'm going to go ahead and write the second one because we do have to check for it. And we'll get there when we get there. So here we're going to have sine of 30.6. So sine of B over B. And then we have to find C because that's the only other variable that we have, 4.454, excuse me. Then we're going to cross multiply. You always want to cross multiply the two places where you have numbers. Those will get multiplied, and then you divide by the other number, so we'll divide by that. When we do this, we're going to get sine of C is equal to 0.311. You'll take the inverse sine of both sides. And you'll get C is equal to 18.1. And again, you should have already done this, or you should be doing it ahead of me, not just copying this down. It's not going to help you learn to just copy it. So that's the first triangle. This is 18.1 degrees. So that's the first C value. The second C value is that number subtracted from 180. So the second C value is going to be 161.8 degrees. Again, it's 180 minus 18.1. So when I write that in, 161.8 degrees, the original B value was 30.6 degrees. These two are over 180 degrees. That means that there is no second triangle. Okay, but there will be the first triangle. There'll be one triangle that can be formed by the information that's given to you. So we're going to go ahead and finish this off. We're going to add B and C together and subtract that from 180. And that will give me, let's see, 30.6 plus 18.1 minus 180. I thought I had already done this problem. So we have 131.3 degrees. So we're going to have sine of 131.3 over A equals sine of B over B. Again, use the given information whenever possible, okay? So 7.42. So when we put that in the calculator, we're going to multiply sine of 131.3 times 7.42, and then divide that by sine of 30.6. And you should get the A value is 10.95, which makes that, you have to add 1 to that, so it's going to be 11.0. And that's the first problem. All right. For the second problem, again, same thing, just start by writing the values that you're going to fill in. So they give me A is 144, C is 135 and B is 75. In this case, you don't have an angle and a side across from each other. The letter, you have an A, a B, and a C. You definitely have to use law of cosines to start this. You don't really have a choice as to which law of cosines formula because they give you the A variable. So we're going to use the A squared formula. So we will have A squared equals 75 squared plus 135 squared minus 2 times 75 times 135 times cosine of 144. If you multiply all that out together, you're going to get 40,232.5. And then you're going to take the square root of that, and all the numbers that are in your calculator, and you're going to get 200.6. Okay, so that's the A value. Then again, we're going to use law of sines next to finish this. And when you're using law of sines, you have two choices. We can go B or C. We always going to want to do the smallest one. We're using law of sines. Okay, so we're going to do sine of 144 over 200.6 equals sine of B over 75. If you cross multiply there, again, you're multiplying these two together and then dividing by 206. You end up getting 0.219. Then you're going to do the inverse sine of both sides. And you'll get that B is equal to 12.7. If you add those two together and subtract that from 180, you're going to get 23.3 degrees for angle C. You never have to check for a second triangle. It's never ambiguous. They're called ambiguous cases when you do, when you're doing law of cosines. For the next problem, and again, the reason I'm going fast is first of all, because you can pause the video, and second of all, because you should have already done these before you check your work. All right, so for number 3, again, we start with this. They give us C is 345. A is 534. And angle C is 25.4 degrees. Sorry I gave you such big numbers. I think I just got these from the book. We are going to be using law of sines because we have an angle and a side next to each other. And we do have to check for a second triangle because you're only given one angle and it is less than, it's not acute. I mean, it's not obtuse, excuse me. So you do have to check for a second triangle. Okay, so we're going to start with the first triangle here, triangle 1, and see what we get. So we get sine of 25.4 over 345 is equal to sine of A over 534. Again, cross multiply, multiply those two together, and then divide by 345. That should give you sine of A is 0.663. Then you will be doing the inverse sine of both sides. That will give you A is equal to 41.6 degrees. Then we're going to get the second A value. That's A1. So A2 is 180 minus this. So 180 degrees minus 41.6 is 138.4. And then because angle A and angle C, if you add those together, are not over 180, that means that you will have a second triangle. Okay, so if I add these two together and subtract that from 180, then that gives me 16.2 degrees. It's a small angle, but it is another angle. For the top triangle, if I add these two together and subtract that from 180, this is 113.0 degrees. So again, for the top one, I'll be using sine of 25.4 over 345. And I'll be using the same thing for this bottom triangle because those are the given information. I need to figure out b. So I'm going to use sine of 113 over b. And on the bottom triangle, I'll be using sine of 16.2 over b. When I cross multiply for the first one, you're going to end up getting b is equal to, and again, you're multiplying these two together, and then you're going to divide by sine of 25.4. So for the top triangle, you're going to get b is equal to 74.0. Oh no, I'm sorry. You're going to get 740.4 because it has to be the longest side. And then for the second triangle, you're going to get b is equal to 224.4. And again, in this case, you're multiplying these two together, and you'll divide by sine of 25.4. So that's the type where you're given some information and you end up having two triangles. For number 4. For number 4, again, I'm going to start this the same way as I started the rest of them. So A is, B is, and C. The given information for number 4, B is 105, C is 38.5, and C is 78. So again, just like last problem, we are going to have to check for a second triangle. So we have A, B, C, and A, B, and C. And the reason I'm using sine, again, is because I have an angle and a side that are across from each other. The reason I know that I'm checking for two triangles is because they only give me one angle, and that angle is acute. Okay, so I do have to check for a second triangle. So for the first triangle, we have sine of 38.5 over 78 is equal to sine of b over 105. Again, cross multiply, divide by 78. So you're going to get sine of b is equal to 0.838. Then you're going to take the inverse sine of both sides, and you're going to get 56.9 degrees. Then we're going to solve for B2. So we're going to take 56.9 and subtract that from 180. That gives me 123.1 degrees. These two angles are not over 180, so you will have a second triangle. Again, we're just going to make sure that the angles add up to 180. So that would make that 84.6. These three angles have to add up to 180, so this would make this 18.4 degrees. To finish off, we'll do sine of 84.6 over A, and then the given information, which was C. So sine of 38.5 over 78. If you work that out, you end up getting A is equal to 124.7. And then for the second one, you're going to do sine of 18.4 over A. And then again, the given information, which is sine of 38.5 over 78. If you cross multiply here, you get A is equal to 39.6. Okay, for number 5, let's go ahead and start like we do all the rest of the problems. In this case, they give us C is 326, angle A is 111 degrees, and angle B is 41 degrees. So when they give you two angles, these are the easiest types of problems to do. First of all, there's only one triangle for sure. And second of all, it's law of sines, and law of sines is generally easier to do than law of cosines. So when they give you two angles, You can go ahead and solve for the third angle immediately just by adding them together and subtracting from 180 degrees. And then you can just do law of sines to finish this up. So we're going to have sine of 28 over 326. We have to use that. Equals sine of 111 over A. And then we have to do sine of 28 over 326 again, because it's a given information, and then sine of 41 over B. For both of these, you can just cross multiply these two together and then divide by sine of 28. And then for this one, you can multiply these two together and then divide by sine of 28. So for the first one, you get 648.3. And for the second one, you get 455.6. So 648.3 and 455.6, and you don't have to check for a second triangle because you have two angles already. For number 6, again, just start off ABC and side ABC. So A is 60 degrees, B is 30, C is 45. This is definitely law of cosines. For law of cosines, you're given one angle and two sides, or the letters are all different. So you have an A, a B, and a C. And we don't have the side across from the angle, so we can't use law of sines. We do have to use the A squared formula, but you do not have to check for a second triangle. So A squared is equal to 30 squared plus 45 squared minus 2 times 30 times 45 times cosine of 60. Make sure you put cosine, not sine, at the end of that. You run that through your calculator all at once, making sure you're using multiplication here and not parentheses, just to do 2 times that. You end up getting 1575. The reason that it's an exact number and not a decimal is because cosine of 60 is 1/2. Okay, so A is equal to 39.7. We're going to finish by using law of sines, and when you do law of sines and you have two choices of angles, you always, or sides and angles, you always want to do the smaller one first. So we're going to do sine of 60 over 39.7, sine of B over 30. You end up getting sine of B is equal to 0.654, etc. And then you do inverse sine of both sides. So B is equal to 40.9. And that's degrees because that's an angle. And then all three angles have to add up to 180. So that's 79.1 degrees. And again, double check that the biggest angles across from the longest side. So angle C is the biggest, so it has to be across from the longest side. All right, and again, you do not have to check for a second triangle because you use law of cosines. For number 7. Number 7, we have A, B, C. So B is 112, C is 58, and C is 39 degrees. So we are going to have to check for a second triangle because we have an angle that's acute. And we have an angle across from a side, so which means we're going to be using law of sines. All right, so for the first triangle, we're going to use sine of 39 over 58 is equal to sine of B over 112. When you cross multiply here, again, you're multiplying these two together and dividing by 58, you're going to get sine of B is equal to 1.215. And you might notice this is over 1. Anytime that happens where you get sine of B is equal to a number bigger than 1, or cosine of b is equal to a number bigger than 1, that means that you're not going to have an answer, because when you put inverse sine of this in your calculator, you're going to get an error. Your calculator is going to give you an error, which means that there is no triangle with these values. Okay, so we don't have one triangle, we don't have a second triangle, we don't have a triangle at all. For the last two questions, I just want you to find area. Okay, and so finding area of a triangle depends on what they give you. So if they give you 3 sides, like this one, then you're going to be using this area formula. The semi-perimeter minus the first side, semi-perimeter minus the second side, and the semi-perimeter minus the third side. You multiply all those together and take the square root. In this case, they gave us an A, a B, and a C. So if you were to draw this picture, they give us C is 25.4, A is 7, B is 9. So what they've given us is side angle side. And that's when you know that you're going to be using the second formula, which is 1/2 A times B times sine of C. Okay, and you don't have to memorize those formulas. They will be given to you. So you can use those formulas. You just need to know when to use which one. So again, this formula is when you're given 2 sides and then the angle in between them. And this is when you're given 3 sides. Okay. All right, so for this question, we have 1/2, 7 times 9 times the sine of 25.4. And if you run that through your calculator, you're going to get 13.5. And then that's going to be square units. We don't know what the units are, but we do know we're finding area. For the second one, first you have to find perimeter. The perimeter is 144. That means that the semi-perimeter is 72. So the area is the semi-perimeter, which is 72. And then it's 72 minus the first side, the 72 minus the second side, and 72 minus the third side. So that gives me 37. So if you run that through your calculator all at once, you end up getting 399,600, which is 632.1 units squared. So that's a review of section 9.3 and 9.4.